Okay.
Said two
So we're
groups
gonna
selector
have
valves,
a,
right?
so let's say B plus.
We're gonna have a
The following
B
sequence.
minus,
Okay, so A plus,
C plus,
C minus,
yeah,
A minus. Okay,
Mm.
so that's so so this is the sequence. So you know, right, that
Yeah.
A means
Yeah.
cylinder A is extending. That's the plus. Okay, so plus is extending, minus is retracting. So now what we need to do is we need to separate this into groups. So each group can only have one letter. I mean, it can't have repeating letters, and and it must be as big as possible. So A, B, we can form that as a group because there B is it's repeating, so we have to split the group there.
Yeah.
And then B minus, C plus, C minus. So there's a repetition there, so we need to split. Then so now so we've got three cylinders A, B, and C. So we'll begin drawing our diagram. So we'll show this as cylinder A, and there's the piston. Okay, just label it A, B, and we'll call this one C. Okay, um, so each cylinder, okay, it's got a port over here and over there. So if you push in air into there, then the cylinder will extend. Yeah. So and in this one, if you push air in there, it'll retract. So what we're gonna do is we're gonna put a we call it a directional control valve because it controls the direction of the cylinder. So the directional control valve, it looks like this. Yeah. So it looks like this. Okay. Okay. So basically, what the direction control valve does is it it's connected to. Sorry, this is not the directional control valve. Sorry, that's not the directional control valve. The directional control valve is a 5x2 valve, so it has five connections on each side. So the DCV looks like yeah. Okay. Okay. So the way it's connected like that and like that. Okay.
Yeah.
So what happens is okay, and so on the bottom edge, okay, this is the input of the cylinder. So pressure will come in there, and these are our two outputs. So in this case, pressure coming in will go in there, push the cylinder, and air that was here will just escape through here. This is just an escape port. And if you shift this DCV across, then this will be here. And
the input.
yeah, this will be the input. Input will be going to this valve, and it'll push the piston across. So that's how the DCV works, and each of them has a DCV. So this is the other one. Okay. Okay. So yeah.
So this is a 5x2 DCV, right?
Yeah, this is 5x2 because it's two choices basically, and each of them has 1, 2, 3, 4, 5 ports.
So when to use 5x2?
So the 5x2 is for DCVs, and we're gonna see also a group selector valve. So we're gonna draw a group selector valve somewhere here. GSVs.
Okay.
Okay.
Mm.
And limit switches, which I'll explain now, they have 3x2 valves.
Okay.
So so these groups, these DCVs, okay, they change the direction based on a certain sequence. So this is the sequence, and so when A is extended, then we know that B needs to now extend. So the extension of B
Oh, I see.
must be somehow related to the extension of A. Okay, so it must be controlled by the extension of A. So what we do is we put limit switches here. Okay, so we labels A0 and A1. So when the piston reaches A1, okay, so when it extends across there, it will activate this limit switch.
Yeah.
Okay, so the limit switch, if I can draw it for you, okay, I'll draw it. We said A1, so once A1 is activated, we know that B must extend, right?
Yeah.
So what happens is, so we have B connected in the same way as A was, so it's connected like this as before. And in order to extend B, we need to push this block across to the right.
Yeah.
Okay, so in order to do that, we denote this symbol. Okay,
Yeah.
so as soon as a pressure is received in this port, this will move across. Okay, so this will be connected to A1. Okay, A1. Okay, and note I'm drawing. These ports are going to the blocks on the right. Okay,
Yeah.
as you can see, I'll explain why soon enough. Okay, so what happens is this is a limit switch, and the limit switch looks like this. That's what I was drawing there by mistake. Okay, so the limit switch looks like that. So what happens is, okay, the limit switch has a little activation roller over there. So as soon as A goes to A1, then the roller gets pushed and this shifts across.
Yeah.
Okay, and the supply, okay, will push this across. Okay. So a way you can think about this roller is basically, if I'm gonna just draw the shaft of the piston there. Okay, so you can sort of think of the shaft as having like a little knob there, and then if this is the little that's the roller. So as soon as the piston moves across, it'll push up the roller, and then this goes across. Okay, so that's basically how it looks like. Okay, so then okay, where were we? Okay, so this needs to shift across, and it'll supply a pressure to push this across, right? So now, okay, now another thing that you must remember is each of the directional control valves have their input from the manifold. Okay, so we represent the manifold with these circles, and the manifold is basically like the pressure supply. So like it's just the supply of the pressure. Yeah. So okay, so they're each connected to a pressure supply. And now remember, I told you that I'm drawing um, these lines connected to the right block. Okay, so the right block is the block when A1 is false. Okay, and the left block is when A1 is true. So initially, if you look at our sequence, A1 is false because at the beginning, right at the beginning, the cylinder is at A0. Okay, so A0 is true, A1 is false because the cylinder is initially retracted. It's at the start. So that's why we draw it over here because it's deactivated. Okay. So that's for cylinders which have a like an input condition. These don't have like a condition, like they're not activated by a rotor. So, but initially the cylinders are connected in this way because initially all the cylinders, if you check the sequence, initially all the cylinders are retracted. Okay, that's why they're all drawn to the right. I didn't draw this one. But I mean, for example, if one of them was initially extended, then you'd have to draw that one connected to the left block. Okay, so everything we connect relative to the initial condition, to the starting point, or yeah. So A1, we said it pushes this across, pressure goes up to B, B extends, okay. So B extends. Okay. So let me draw this over here. Okay, so A extended, activated A1, which caused B to extend. B extending activated B1, which is going to cause B to retract, and then uh, that's going to uh, activate B0, which causes C to extend, which activates C1, which causes C to retract, which activates C0, which causes A to retract, and A retracting activates A0, and we connect that to a start button, which I'll show you now. And the start button allows you to actually like just press start and make the whole process automated. Okay. Um, so we were here. We said that A1 activated B to extend. Okay, now B1, as you can see, B1, at B1, our group gets shifted to the next group. So before we were at group 1, but after B1, we're going to be at group 2. Okay. So with pneumatic sequencing circuits, we have when we have 3 groups, we'll have the same number of control lines. Okay. So control lines are basically lines which supply the group. So this is control line 1, control line 2, and control line 3. So control line 1 will supply group 1. So it will supply all those actions. Control line 2 will supply those actions. So you'll see how that works soon. Um, and yeah, so those are the 3 control lines. And to switch between the control lines, we have group selector valves. Okay, so we'll have one there and we'll have another one here. And by the way, I just made a little mistake there. I forgot to connect A1. So for all the limit switches, you connect the input port to the control line of its group. So A1 was here. It's in group 1. A1 is due to A plus, and A plus is in group 1. So we connect it to the control line 1. Okay. So you always connect. So connect limit switches to its group. Okay, that's important. Now, okay, so now we need to, so B1 must somehow activate B minus, okay, but at the same time it must shift group selector valve 1 to deactivate control line 1, and it must now activate control line 2, because now control line 2 is the one that supplies everything that happens in group 2. Okay, so our group selector valve looks like this. Okay, it looks similar to the directional control valve, so it's got that same okay, so that's how it looks like. Okay, and we said that the input port is this port. It's the middle one, right? And we know that initially the initially this group selector valve is powering group 1, right? That's the initial, because initially we're in group 1.
Yeah.
So we're initially powering group 1. So the input must be connected to group 1. Okay. So that's group 1. And the other output of this must be connected to control line 2. Okay, the reason I connected to control line 2, because as soon as we switch this across, the input is going to be connected to control line 2.
Okay.
Okay, so what we need to do is we need to take limit switch B1 and cause it to shift this thing across. Okay, so limit switch B1 will be connected here. Okay, because remember that arrow means that
Yeah.
pressure
Push.
shifts it, yeah, pushes it. So I'm gonna draw B1 here. Okay. So you always draw your limit switches. The limit switches that change the group are always drawn below the control lines because they're gonna be connected somehow to the group selector valves. Okay, so the limit switch looks like this. Okay. And now B1. Okay, B1 is connected to here. The output is connected to here. Now, is B1 initially activated or deactivated?
Activated.
No, it's deactivated because initially the piston B is going to be retracted. So initially B0 is activated and B1 is deactivated. So B1 is deactivated, so it's connected to the right hand side. Okay. So initially it's like that. And then remember B1, okay, it's a result of B plus, right? B1 is due to B plus. Well, it's activated because B extended. Okay, so therefore B1 is part of group 1. Okay,
Yeah.
so therefore its input comes from group 1. So you'll have to draw a line across there and there. Okay, so that's the input and output of B1. Okay, and then after B1, so B1 activates this group selector valve, and the group selector valve puts down a pressure of control line 2, and our control line 2 must cause B minus to retract.
Yeah.
So to make B minus retract, we need to put pressure on that side. So we just connect that directly to control line 2 because that's going to be activated by the group selector valve. I should actually label it. Okay. Now, the next thing that we need to do is we need to connect group selector valve. Sorry, now we need to take B naught. We need to consider B naught because now B minus is retracted and B naught is activated, and B naught must cause C to extend. So it must be connected to that. This is our B naught. Okay. So it looks like that. Okay, so is B naught initially activated or deactivated?
Deactivated.
No, activated because B naught is initially retracted, right? Sorry, piston B is initially retracted, so B is initially at B naught, so it's activating B naught, if that makes sense, because here's B naught, so the piston is going to push the knob of B naught, so it's initially activated, right? Because yeah, it's yeah. So like this is B1. If this is piston B, B1 would be there, and B naught would be here. So it's initially activated. because it's at B0. But now when the piston pushes forward, then B0 will drop down, it'll be deactivated, and B1 will be pushed up, so it's activated. So that's how it works. Okay, so since it's initially activated, we put it to that side. Okay, and B0 is part of group 2, so its input comes from group 2. Okay. Oh yeah, and I forgot, also these are all spring returned, because as soon as you go past there, then it's almost like a spring that pushes it back. Okay, so spring return, all the limit switches. Okay, so then the next one is C1. C1 is connected to group selector valve 2. Okay, so we have another group selector valve now. Okay, GSV2. Okay, also same configuration as group selector valve 1. Okay, now C1. Okay, so what happens is we have, okay, in GSV2 will be connected to the manifold or the pressure supply, right? Okay, so what they do is they connect GSV2 to the pressure supply. Okay, so I'm just going to draw it here for now, but it might be that side, we'll see. And the output will be connected to, so if we connect the manifold here, then initially we've also got pressure on here, so therefore this must be connected here, because initially we've got pressure coming from the manifold to here, and initially we have pressure on control line 1, because control line 1 controls group 1, and initially we're in group 1, so therefore we need pressure on group 1, so therefore the missing link is this wire or that tube over there. Okay, so that's why I drew it there. Okay. Now, okay, so if that's the case, and now what group selector valve 2 must do is it must somehow link groups 2 and 3. Okay, because we're now in group 2. Okay, we were in group 2, and now C1 has to move this from group 2 to group 3. Okay, so if you connect group 3 here, okay, so we're going to connect group 3 here, then as soon as this shifts to the right, okay, then the pressure from the manifold is going to be connected to group 3, right? The pressure will be deactivated here. Okay, pressure will be deactivated here on this tube, and this tube is controlling groups 1 and 2. I mean, this group selector valve was controlling groups 1 and 2. So it's so groups 1 and 2 we know don't have pressure because there's no pressure coming here. Okay, and so we've shifted it across. So only group 3 is getting pressure now. Okay, and what we also need to do at this point is we need to reset group selector valve 1, because remember when we moved to group 2 we pushed this across. So to push it back in preparation for when we start again, we need to therefore put a from group 3, because now we're activating group 3, so we need to put pressure on here as well just to return it back to its original position. Okay, and what did we say? In order to push this to that side, we need to now connect our C1 limit switch to this. Okay, and remember C1 is initially, let's check, so the initial condition is that C is retracted, so initially C1 is deactivated. Yeah, so it's going to be connected there. to the right hand side of this thing. Okay. And so this is C1. And remember, we always connect our limit switches to the group it came from. So C1 came from there, so that's group 2. So we connect its input to group 2. Okay. That's that. Okay.
Everything's still fine.
Huh?
Everything's still fine.
Okay. So then, so once we've connected C1, and that pushes over there. Okay, so C1 is all connected. We've got connections at its input and output. And now C must now retract. So this group selector valve has activated group 3, but it must cause C to retract. So therefore we connect C directly to control line 3, just as we connected B over there directly to there. Okay. Now, once C retracts, C0 will be activated, and C0 must cause A to retract. So A must retract. Okay. Is it this side? Yeah. Sorry, retract. Yeah, so it's this side. Sorry. Okay, so I'm running out of space at the bottom, so I'll just... Oh wait, no I can't. Let me move it here. Okay. Just to fix that out. Okay. So now we're gonna have C0 connected here because it has to cause A to retract. So C0 is initially activated. Okay, because it's initially C is at that position. So we know that this is going to be connected here, and our limit switch looks like this. Okay, and the input is connected to its group, so its group is 3. Okay, so that's how we control there. Now when A is retracted, it activates A0. Okay, A0 must activate start, and it must change the group. Okay, must change the group. So A0 must activate A0 and start must change the group, and the group must then change the pressure to control line 1, and control line 1 must then activate A plus. Okay, so let's try draw that. So A minus activates A0, and A0 is connected to start. Okay, and remember we said that if the limit switch is between two different groups, then we need to draw it somewhere around the group selector valve, so at the bottom. Okay, so since we're drawing it here at the bottom, it will have to be connected to... Okay, so remember we moved this across to put the pressure onto group 3. So, and we already reset this. So the only thing we need to do to activate group 1 is to push this, reset this, exactly. So now we need to put pressure on there. Okay. So what we do is we connect that to start. Okay, so our start is initially deactivated. So before you start the machine, or before you start the sequence, it's initially deactivated. So we represent a start with the push button. I think the symbol is like this. I can't remember exactly. But it is similar to a limit switch. It looks like this. Okay, so it's initially deactivated. So initially, it will be connected there. And the input will come from A0, because start is controlled by A0. Okay, so we connect that to A0, so A0 will be here somewhere. Should label this start. This is A0. Okay. A0 is initially activated. Okay. So this is going to be connected to here. This is going to be our A0. Okay. Now, and A0's input is from group 3, right? So A0's input will be from group 3. So I'll bring it across to here. So that's group 3. And I forgot to draw springs. There's no spring there's no spring for the start button, because once you push it, it's gonna have to stay there in order to keep the pressure going past. Okay. And there's also a spring there. Okay. So then that should complete our drawing. Yes. Okay, so we drew everything relative to the initial conditions, right? So this is before we press start. So before we've pressed start, um, initially we've got pressure going. Oh, I forgot also to connect this. Sorry, this needs to be connected. So okay, so start resets this. The pressure goes back, and once this line is connected, we have to activate the DCV of A in order to push it to cause it to extend. So therefore we need to connect that as well. Okay, so let's just see if it's correct. We have pressure coming in from the manifold initially, goes up to there, and this is the initial condition, and then it's connected there. That's connected to this here. This pushes it across, causing A to extend, which is not right because we haven't pressed start yet, so it shouldn't start. So actually this is a mistake. These should be initially connected on that side. Okay, so let me Tipex this. So initially we connected to this side. Initially we connected to this side. Okay, and this is connected to there. Okay, so that's the initial condition, and after you press start, then it'll come across. Okay, so this will be connected to the manifold. So initially our pressure actually looks like this. I've drawn pink all over the place already, but okay, so initially our pressure will come in through here, go across there, and then it'll activate group 3. Okay, so group 3 will be activated, and initially it'll be connected here. Okay, it'll be connected through here. A0 is initially activated as we have here, and it'll stop there. Okay, that's the initial pressure line right over there. Ignore the other pink there, that was a mistake. And as you can see, there's also pressure here, so definitely C is retracted. And where else do we have pressure? Here, so definitely we are ready to begin with group 1 because it's reset. And as you can see also, A is retracted. Okay, so that's all the pressure coming from before we press start. Okay, so Definitely these two are retracted. You can assume that this is also retracted from the previous, uh, well, whatever happened previously. Okay, so as soon as you press start, then this thing gets pushed across, so we're going to have pressure here, right? So since we have pressure here, this is going to switch across. So we're going to have pressure on here coming from the manifold, because now this is going to shift across, so this is going to be connected. So we're going to have pressure there, pressure here, and now we're going to have pressure at group 1. Okay. So we're going to have pressure on group 1. Group 1 is going to have pressure on here. Okay. This activates A. So pressure on here moves this across and activates A. So A comes across. A1 is therefore activated, right?
Yeah.
So since A1 is activated, the pressure coming here will then be able to come across there, right? B will be activated. So B will be activated, and since B is now activated, the pressure from A will come across to B, and since B is now activated, the pressure will continue across to there, and now group selector valve will be shifted across.
Yeah.
Okay, so now group selector valve is shifted across. Let me choose another color. So now the pressure here, remember we still have pressure here, is now going to be diverted across to there. So our pressure is now going to be on this line. Okay, since this is pushed across. So now since we've got pressure here, we'll have pressure going up to, let's see, B there, B minus, because before we had pressure here, so it was there, so now we're pushing it back. So we've got pressure back, sending, so B minus retracts again. B naught is activated, so the pressure from here, since B naught is activated now, it can go across to here. That pushes this across, and so C extends. C extending causes C1 to activate, so the pressure from here, okay, it can go across because C1 is now activated, so it goes through there and selects group selector valve 2 to go across, and so now it's like reset to this position. So now the pressure again comes up here, it can go up there to C minus, so C retracts, and also the pressure comes across here to cause A to retract. So now B, A and C are all retracted, and the pressure comes back here, and since we already pressed start, the pressure continues across and the cycle repeats itself. So that confirms that our circuit is working.